Good afternoon and welcome to another Research Cafe. This session and this seminar is meant to allow everybody to learn on what's going on, what research is going on across our campus. We usually invite two different speakers to these events from very different disciplines and have them talk broadly about their research. Today, it is my great pleasure to introduce Dr. Lilah Besser, who will be our first speaker. Dr. Besser is an assistant professor in the Department of Urban and Regional Planning and also an eye health fellow. She has a BS in biology and a Master's of Science in Public Health and Epidemiology and Environmental and Occupational Health, and a PhD in City and Regional Planning. And I'm just going to turn it over and have her tell you a little bit about her research. Thanks, Lilah.
Cool. There we go. Okay, so before I kind of go into my research, I've been prompted to give you a bit about myself. So I'm just going to give some interesting factoids. I've lived in a number of places in the US. I was born in Rhode Island, and I spent my childhood in North Carolina, and then also, of course, lived in Florida. Went to college in Georgia. Most recently lived in Washington State before this, Seattle. And then moved here to Florida. So I'm half Filipino. My mom is from the Philippines and she came here when she was 19 to work and stayed there ever since. Married my dad, who's a very white man with blonde hair and blue eyes. So this is what comes out of that. And so through my childhood and early adulthood, I traveled to the Philippines every 3 to 4 years. And unfortunately haven't been there since 2006, I think. I was recruited to FAU in 2018, and that's when I moved from Seattle. And if you don't know where the Philippines is, it's over there in Asia, and it looks it's 7,000 islands. That looks like kind of like a man kind of bent over with his arm forward or holding a cane or something. So even though I've been living here a few years, I really miss the Seattle landscape. So I'm still kind of a Washingtonian at heart. Especially during the summers, people think of Seattle as a gray space, just raining and gray, but in the summers, this is basically what it looks like. It can be cold still, but very, very blue, beautiful landscape. We spent summers every weekend exploring and hiking, and my son always had his birthday parties at the park outside. So enjoying nature. So obviously I'm a proud mom of a 12-year-old boy now. He's doing the virtual school thing and just trying to survive. And he's obviously very silly and a lot of fun. So we're doing okay. My primary hobby is nature photography right now because it allows me to get outside and keep my social distance from other people. I started doing photography when I moved here in Florida to try to kind of explore the area and then potentially meet other people. So I have met a few other photographers through that. And if you're interested in gadgets, then I use a Sony Alpha 6000 and a 16mm prime lens and a 55 to 210mm zoom. And then along with photography, I like to travel when it is safe to do so. So I've been to a number of places. And my parents really shared their travel addiction with me. I don't know if that's good or bad because I'm going crazy right now, as everyone else is too, I know, but I can't wait to get out and travel as soon as it's safe to do so and get on a plane. And traveling has really shaped my worldview, including my academic interests in urban planning. So that helps explain why I'm kind of interested in urban planning. And my parents and many of you may not know what urban planning is. So that's my PhD is in city and regional planning. And it's the study or profession dealing with the growth and functioning of cities and towns, including environmental concerns, zoning, infrastructure, and so forth. And urban plans and policies really shape our built environments and can have long-lasting effects to our transportation systems, of course, our built environments, social kind of dynamics, economics, and even health, which is my main interest. So the built environment includes those man-made physical environments in which we live, work, play, and learn. And the area where I'm really focused in on right now is looking at parks and green spaces. So I also have that master's in epidemiology, and a lot of people are also puzzled as to what that exactly is, even though with the pandemic, it's been a little bit more clear. But I'll just kind of briefly go over it. So it's the study of the origins of disease and also the risk factors and preventative factors for disease and well-being. So not just focus on disease, disability, but also health, well-being. Some epidemiologists focus on monitoring disease trends at different ages, across populations, different regions. We are trained primarily in and focused in on research study design and statistical analysis, so we can make good conclusions from rigorous data. So the emphasis of our work is health promotion, disease prevention, and health at the level of the population. So not individual level health like doctors tend to be focused on, but more at bigger scales, such as neighborhoods, states, or populations, such as immigrants, children. So my mentor right now likes to endearingly call me a platypus. So I combine these kind of disparate fields of interest, urban planning, Alzheimer's research, and epidemiology to make kind of a unique field of research. So before I dive into the studies that I focus in on, I just wanted to talk about the kind of model, the conceptual model that informs these kinds of community environment and health studies that I do. And that's the socio-ecological model, which posits that there are these multiple levels of influence to our health. They start at the individual level at the bottom of that upside down triangle, and that's what most people think about when they think about their health: genetics, diet, socioeconomic status, smoking. But it can go all the way up to higher level influences, including your family, community, neighborhood environments, regional and national, such as health reform, healthcare policies. So of course, my focus is community level. So green spaces, but also more broadly built environments, and also social environments and how those are related to the built environments. And that includes things like crime. So my research program is focused on providing evidence for community environments we can promote through plans, policies, programs, and interventions to support lifelong healthy behaviors, and focused in on healthy behaviors that can be promoted to then further promote healthy brain development during childhood, and also healthy brain aging throughout adulthood and late life. And that's to help reduce the risk of Alzheimer's disease and associated disorders, dementias, which primarily manifest in the later ages, 65 and older. And also help older adults age in place if they choose to do so. So stay in their neighborhoods and homes as long as they can without moving on to assisted and nursing facilities. And then the current emphasis for my research is what I'll be talking about in the title of my presentation. So the contact with nature, and how can that benefit our brain health? So what do I mean exactly? It's pretty self-explanatory, but viewing, just sitting in, interacting in, and spending time in, possibly exercising, doing other activities in green spaces such as parks, open spaces. But it can also be, and that's, of course, my main focus, but it could also be blue spaces, and that's beaches, urban waterfronts, wildlife viewing, and also interacting with wildlife. So how may green space exposure be related to brain health? And I'm just going to quickly go through this model on the right. I know it's a lot of information, but it just kind of gives you an idea of how what is hypothesized, how these things are related. So green space can be overall level of vegetation, greenness, forest, greenery, just overall, or specifically allotted spaces such as public park spaces. And those have been associated with these intermediate outcomes, including mental health, such as reduced stress, anxiety, depression, also reduced air pollution exposure, increases in physical activity and social engagement. And then those activities in turn have been, and factors have been associated with brain health indicators in early life, including brain development, but also in adult and late life, such as stress regulation, inflammation, vascular integrity. And in turn, those brain health indicators, if going on long enough, and that benefit or detriment to those things can affect long-term brain health outcomes. And here are just some examples of the main ones that I tend to focus on. These are brain MRI or magnetic resonance imaging measures of brain health, and also at the bottom there, cognitive functioning, which can be measured via cognitive testing. So here, mention some of the brain health measures. Typically in these kind of studies, people will use imaging, brain imaging, cognitive testing, or there are these other miscellaneous ones such as fluid biomarkers, cerebral spinal fluid, or EEG brainwave measurement. So I know this is very busy, but this is, I'm going to dive into a few of my studies. So this one is a, what's called a scoping review. It's basically a literature review that's under review at a journal right now. And before I started doing, a lot more of these studies, I wanted to see how many have been done and what age groups have been focused on, what countries, what measures have been used. And so this is a listing of what I found that had been published in the scientific literature up to 2020. So there's 22 papers, 13 on older adults, which is the age group that I tend to be focused on because of Alzheimer's disease. And just the punchline is 14 of those 22 papers found positive associations. So the more green space you have in your neighborhood or the more exposure you have to green space, the better your brain health. And most of those studies to date have focused on cognitive testing and cognitive health benefits. This is another study that's currently under review, looking at the park space in your neighborhood, how much of your neighborhood space is allotted to parks, and whether it is associated with change in cognition over time in older adults. So this is using the multi-ethnic study of atherosclerosis, or MESA. And in that map there, you can see the 6 sites that this is an ongoing longitudinal cohort study of participants that were enrolled back in 2000. And they're still continuing to be studied. This study that I did has 1,700 participants focused on older adults. You can see it's a diverse sample that was intentional in how they enrolled them initially. And the study found that greater neighborhood park access, or having more park space in your neighborhood, was associated with maintained improved global cognition when following these individuals over 6 years. So compared to those with less park space who had more decline generally, those with more park space had a positive cognitive trajectory. So I know this slide is busy, but here's another study, and I find looking at the brain magnetic resonance imaging outcomes to be really intriguing and interesting, because it's really getting at, is there a biological effect versus cognitive testing, where you're not sure if there's some things that are kind of affecting cognitive tests that may not actually be happening in the brain. It might be a social thing. So this study uses the cardiovascular health study, which started in 1989, and looking at green space in the neighborhood again, but these brain imaging measures, and here I'll focus on ventricular volume. So the ventricles, you can see in this image on the top right, there's 4 in the brain, and you can see lateral ventricle, third ventricle in the diagram. And those are spaces in which cerebrospinal fluid is produced, transported, and removed. And the CSF, is the buffer against shock, and also kind of brings in nutrients and removes waste from the brain. So if those ventricles tend to get bigger with age, normal brain aging, but then with Alzheimer's disease, may get even bigger than normal compared to others without Alzheimer's disease at that same age, because the rest of the brain is shrinking or atrophying. So if there's some positive benefit, then you would expect to see less of that increase in size of the ventricles over time. So we found having more green space in your neighborhood in the 5 years before getting the MRI in older adults was associated with less or lower ventricular grade. So less brain atrophy, meaning a positive benefit to brain health. And lastly, this is my NIA, or National Institute on Aging, K01 grant. It was awarded in May of this year, so it's just getting started. It's using existing data on individuals followed annually at 3 Alzheimer's disease centers across the US. So that's UC Davis, Washington University in St. Louis, and Wake Forest University in North Carolina. And the goal of the study is to see whether in early, mid, and late life is exposure to neighborhood green space associated with brain aging in late life. So the kind of innovation or the exciting thing about this study is using geographic information systems to derive these green space measures at the neighborhood level. So if you don't know GIS, you can use this program ArcGIS to basically integrate spatial data, like kind of the boundaries of neighborhoods and administrative boundaries such as census tracts, with other data that you're interested in. It could be health or environmental data. And you can map it, and it's you can do visuals like this that you see, but you can also then output new measures that you can use in your analyses for health studies. So that's what we'll be doing, and we're getting GIS-based green space measures of distance from home to the nearest park space, percent of the neighborhood composed of park space, and this thing called Normalized Difference Vegetation Index, or NDVI, which is a quantitative measure of the amount of healthy vegetation in an area. And it's using satellite imagery. And I won't go into the details there. The brain health outcomes are an annual battery of cognitive tests. 2 of the centers that are included have followed participants back since 2005, and they're still followed. So we have annual measures since then in multiple cognitive domains. So cognitive domains include memory, which is the hallmark cognitive domain that's affected most in the earliest stages of Alzheimer's disease, but also these other cognitive domains, including attention, language, and executive function, which can be affected in Alzheimer's, but also other dementias. And then for a subset of the participants, they have magnetic resonance imaging of the brain. And so we can look at changes in brain volumes over the time in these kind of biomarkers for Alzheimer's disease. And lastly, in a subset of the participants, this neighborhood questionnaire has been designed for this study, and it's asking for self-report of their socioeconomic status in childhood, midlife, late life, and also behaviors such as transportation use, walking and bicycling in the neighborhood, perceived neighborhood environments, including social and physical environments, and of course, green spaces. So at ages 11, 40, and in the late life period. So this just started in May, and just hired an undergraduate research assistant. We're developing the neighborhood measures, kind of getting all the secondary existing data together, working in it in GIS, but we haven't been able to produce any results yet. Probably nothing for a year or so, a year to 2. And then lastly, I've been kind of encouraged to talk about my interest in collaborating with other people at FAU. And that K01 grant that I just talked about is required to I'm required to dedicate 75% of my time to that. So I have to do the research as part of that grant award, but I also have to do half of the grant is actually doing a whole bunch of career development opportunities. So I have limited time to write more grants. I'm not allowed to, take up that much more of my time for new grants when I need to focus on that one. But I do enjoy writing papers, and I continue to do that even during this the startup of this project. So I would be interested in forming writing groups. I like giving feedback on people's papers. And I'm particularly interested in those with expertise or interest in GIS, but also technologies to monitor movement and exercise health, such as GPS and accelerometers. And then also, of course, anyone interested in Alzheimer's disease, associated disorders, or the natural built and social environments. And that's it. And I have my email there in case you want any more information. And then I just put up a few of my most recent publications that relate to the studies that I talked about. So I'll stop sharing now so we can turn it over.
Thank you, Lilah. Very interesting. So I forgot to mention to everybody, if you have questions, please use the Q&A button in the bottom of your screen. We will ask questions after both presenters have presented. So make sure that you direct your question so I know who the question is for, whether Lilah or David. Okay, so we're going to switch gears a little bit right now, and our second speaker today is Dr. David Kahn. Dr. Kahn is assistant professor in civil engineering at FAU, and he also hails from the West Coast from UC Berkeley, where he did get his Ph.D. and I believe also his master's. And with that, I'm just going to turn it over to David and have him tell us what his interests are. And again, you can ask questions throughout the entirety of the talk. We will go over all the questions at the end of both presentations.
Thank you, Karen, for the introduction. So as you can see in the background, this is a big part of my lab, so I'll explain that in a bit. So besides the just where I graduated from and some of the basic info, I want to tell you a little bit about myself. I've lived in 5 different states, pretty much all over the country: Pennsylvania, Illinois, Texas, Florida, and California. Again, like the previous speaker, I also traveled a lot, and I've been to 35 states and actually driven in all of them, and also 3 Canadian provinces. I've been through some pretty extreme areas. I would say here in North America, as high as 14,000 feet above sea level in Colorado, as hot as 120 degrees in the Mojave Desert several times out west. And this whole experience has led me to really think about the role of transportation and how important it is, not just from a personal perspective, but also that relates to everybody else in their everyday lives. Groceries have to be delivered, and you have to commute to work, and things like that. That's what really sparked my interest in this particular field. And back in the day, back in the era of the post World War period, especially the Second World War, we've been talking a lot about building more infrastructure to give us access to places that were relatively more remote back in the day. Pretty much all of these Western states I've been to, and the Central Plains like North Dakota, South Dakota, but the infrastructure is there right now. It's more so about how we manage our infrastructure, and this is where my area really comes in, which is transportation engineering, and I deal with traffic management and traffic congestion, again, related to how our cities are going to be planned. So very much in line with the urban planning folks. And really the elephant in the room today is not about the physical infrastructure itself, but rather what's going to come out of the latest innovations with automation and connectivity, and what actually is a part of the infrastructure system, which are the users and typically the vehicles that travel on these roadways that we've been building for so many decades. And this isn't just some science fiction. It's actually putting into action, and it's going to be the biggest automobile invention ever since some important things like seatbelts and airbags, and also backup cameras. I'm sure all of you have experience with that, and some of you may have some experience with back in the day when those things weren't available. I certainly know back in the day when my car had cassette players and no backup camera, no anti-lock brakes, and I even remember the days back when you physically have to roll out the window in order to open it. So we've come a really long way, and the next step is going to be automation and things that seem very cool in the media, especially with the latest news, all the hype about Teslas these days, right? So we've been focused a lot on safety recently, especially with the vehicle design in particular, but not so much in the aspect of mobility, right? We care about this single vehicle performance and how is that going to be related, how is that going to be protecting, how is that going to be helping you in terms of a crash or just preventing a crash altogether. And this has been the centerpiece of automation as well and connectivity, but there is a bigger challenge that we have to solve. And you certainly don't want to see something like this on a day-to-day basis from, let's say, 6 a.m. to 6 p.m. It certainly happens in some parts of the world. And having lived in the San Francisco Bay Area myself, and having been to LA multiple times, I can definitely tell you that this is a serious concern. And it's not going away anytime soon. And just to put some stats right there, we're looking at a significant amount of delay. It doesn't really matter what size of the city you're in. It could be small cities, it could be medium cities, it could be large and very large metropolitan areas. And as you can see, this is data collected by the Texas A&M mobility study that they do. And we are in an area that is actually on top of the list. Unfortunately, just like any other major metropolitan areas. Well, we've been building a lot. We've been building infrastructure here and there since the 50s, right? 50s had a huge construction boom on interstate highways, but it's becoming more and more expensive. We're talking about $10 million per mile for an urban freeway, sometimes even more, right? If you look at the example of some tunneling that was done back in Boston, they call it the Boston Big Dig, that was quite significantly more expensive than $10 million per mile. So this is just an average number. But here's the thing, we have all these innovations with automated vehicles and potentially connected vehicles. Can we get away from this expensive infrastructure investment? Sometimes it's just not about the money. Obviously, there's a whole lot of discussion related to gas taxes and how to raise the revenue, but think about the fact that there are places that are just physically impossible. Can we get something out of our current infrastructure without having to build more by using connected and automated vehicles? And the answer is a bit of a mix. And it depends on who you ask and depends on the scenario, right? It depends on what you're talking about, what particular technology you're looking at. It could go one way or the other. It could be negative, it could be positive. So it's not particularly promising as many people in the media have really brought up the hype recently. So let's quickly go over where we are in terms of just automated vehicles, because it's been a hot topic since the beginning of this particular decade. So where we are at the mass market level is we have some degree of automation, which is level 1 automation that can actually allow you to not use the brakes or the accelerator, and the car will brake and accelerate automatically for you, provided that the drivers still have to do all the other tasks. Level 2 is coming up, meaning we can do more than one particular driving task, in addition to just keeping you in a lane and being able to stop and accelerate based on traffic conditions ahead of you. Cars today, well, a very small number of them, Teslas, and then GM is going to roll out some slightly more expensive Cadillacs that can actually make lane changes automatically for you. So this is getting into level 2, and it's going to take quite some time for that to be available in mass market cars and become affordable for the average buyers. But that is coming. And level 3, we're looking at potentially drivers not taking any action, but just having to be in the vehicle and intervene in some circumstances. We're quite a long way from level 4 and level 5, but in the meantime, level 1 is already making a fundamental change to our infrastructure and the way how traffic works these days compared to 10 years ago. And we don't have to wait until the higher levels of automation and those things that may seem like science fiction to you for us to really experience any significant changes. And some urgent action have to be taken as a result of what's been going on. So that's what we're here to talk about. And it's not about how long can we wait and if we have to make any adaptations. It's about, let's collect some information on what's happening now and let's see what is the current impact and how is that going to amplify down the road. So this is just to give you an example. Today, you can buy a car with adaptive cruise control fairly easily, and it's fairly readily available. The way how that works is that you're going to turn it on and set a certain speed, just like how you set a cruise control. But you're going to pick how closely you want to follow the other vehicles in front of you, and then the car following aspect is just automated, right? It can decelerate, it can accelerate automatically for you without you having to ever intervene. Of course, it works in some controlled environments, but you can see that the car is decelerating automatically because there's a vehicle in front and the car doesn't want to follow way too closely. And now traffic opens up, right? Now it can actually accelerate, and you can see there are 3 blue bars here that indicates how closely the driver wants to follow. And further down the road, you'll see that the car can actually automatically decelerate and come to a complete stop in the event of congested traffic, which many of you have seen and experienced pretty much on a daily basis, not during COVID, but back in the pre-pandemic era. And now you can see that the car has made it almost a complete stop in response to the traffic condition. So this is what we're dealing with right now, and the automakers are going to add more functionalities on top of this, right? So this is the first step into automation, and it's not going away anytime soon. Now, let me stop this video real quick. And so we've been asking this question about if this is an alternative to new infrastructure, right? So let's actually do a quick comparison. So today you can pretty much buy a Toyota Corolla that has this capability that can automate the car following. It can take a lot of stress out of the driver and fundamentally change the way how traffic flows, how traffic behaves. And are we talking about, let's forget about the fact that, you know, we have to figure out if this is going to be positive or negative impact, but just look at the cost aspect, right? If the automated vehicle has a potential to make any difference, and let's do a quick comparison. Adjusted for inflation, the prices don't look very different compared to 10 years ago. And keep in mind, this $104.50 increase over 10 years is not just because of, you know, this standard adaptive cruise control feature that is available. I mean, that is pretty much on mass market economy cars. It's also other stuff like your creature comfort, like Bluetooth, you know, Apple CarPlay, Android Auto, just a lot of things that you kind of take for granted these days that weren't available back in the day. So the $100 increase is not just about cars being able to automate themselves. And you can see I have 3 of them. I have 3 of these for my lab to do field testing and real world experiments right in the background. I'm actually not physically in the parking lot, but this is just a picture of the vehicles that I have in my lab. So let's actually look at the characteristics. So this is an experiment back in my grad school work when ACC or adaptive cruise control was fairly new to the market. So if I actually look at what's been happening with adaptive cruise control is that it still relies on sensors, it still needs to react, it still has the flaws of humans. It's going to take time to perceive an object moving in front of you, and it's also going to have a delay when decelerating. See, the brake lights don't come on at exactly the same time. It kind of behaves like any other humans. It needs to judge, it needs to be able to have some time to react. So this prevents them from following each other very closely. And that is one of the big flaws of ACC. It's really not going to have that potential for alleviating congestion. It's not going to increase our highway capacity by a significant margin. In some cases, it actually might make it worse because of this delayed response or just the fact that controllers and sensors also have response delays. The algorithms have response delays. You have to factor in safety into this as well. So that's part of the reason why that we may still get very unstable traffic flow and very much the same, maybe even worse traffic congestion that we see that we see today. Obviously, not during the days of COVID-19. And to illustrate this in a quick animation, what's happening right now in the simulation is that these automated vehicles have some kind of response delay, right? When they have to decelerate and accelerate, just like how you do the stop and go driving in your everyday congested traffic on your way to work, on your way home. What happens is when there is that reaction delay, just like with humans, automated vehicles have this same problem. The cars get further apart. And what we care about in traffic engineering is how many cars can get through a certain section or a certain point in a given amount of time. If they're not closer together, if they're further apart, if you do some kind of data collection to count the number of vehicles that go through a certain point, it's going to be, that flow is going to be less. So this problem is pretty much persistent, and in some cases even worse, depending on who you compare it to. For ACC systems that we've been testing in my group, we've been seeing that compared to the average drivers in typical metropolitan areas that behave more aggressively than rural areas, ACC is actually going to be worse. They take longer to react and take longer to respond. And we would expect some significant reduction in capacity, and we're talking about 20 to 30% in terms of just your average freeway capacity on a day-to-day basis. So this is not really a good news for anybody who is interested in alleviating traffic congestion via automated vehicles. And certainly we have to adapt. The manufacturers don't have much of a concern at this point as to how their controllers are going to affect traffic flow macroscopically, but this is what we have to deal with. And looking forward, I definitely want to have some interactions and also be able to persuade manufacturers to design controllers in a certain way that doesn't negatively impact traffic flow. And same thing as you can see here, when the traffic signal turns green, the reaction time is quite long. This is a video from our field test, and you can see the human-driven vehicle on the left is quite a bit faster, and you can see a larger gap being left between the vehicles. And this is certainly not good if you're concerned about capacity, if you're concerned about reducing congestion. We're actually going the opposite direction. And this isn't just anecdotal evidence. Another video, a day of testing also gave us the same exact result when we actually went out there to many real-world scenarios right around Boca Raton. So as you can see, the light turns green. Well, the ACC vehicle driving in autonomous mode is not behaving the same as humans. As you can see here, at least in South Florida, human drivers are more reactive and more responsive. So the short conclusion is that in the coming years, we're going to see traffic getting worse due to the fact that there is more and more automation on the road in the vehicles, especially at mass market vehicles like the Toyota Corolla that you can buy, and many other vehicles, many other manufacturers have some variations of that. But the problem is really, it comes down to connectivity, which is the piece that we're missing. So there's a lot of push and a lot of talking points about how connectivity is wonderful, but there hasn't been any concrete plans for implementation. So with prototype built back when I was in graduate school, connectivity could really mitigate some of the problems. And you can see a platoon of cars that can follow closely to each other, and they don't really have this particular response delay. And this is because when the vehicles are connected, you can allow for almost simultaneous reaction. So the cars can follow each other relatively closely without having to be concerned about reaction delay and sensor response delay and things that you also associate with humans. So as they follow closer and closer to each other, we would expect capacity to increase and traffic congestion to reduce. As you can see, there isn't much of a delay when it comes to acceleration. They accelerate pretty much altogether, and when they brake, the brake lights come on relatively quickly altogether and without much delay. So looking at this particular video, this is what we're looking at. This is what we strive for, to be able to make a difference in terms of resolving issues with traffic congestion, mitigating the negative impacts of that. We're not just looking at autonomous vehicles, but we're also looking at connected and autonomous vehicles. So this really is the next step. But in the meantime, we have to deal with what we have, and it's going to be quite a while. It's going to be decades of what we call the ACC vehicles that I talked about earlier, that are going to be running on the road and impacting our traffic flow much more negatively than we expect. So looking to the future, as a traffic engineer, as a transportation person, as a traffic flow theorist, I would definitely like to see more knowledge adapting to the fact that vehicles are automated and they behave in this particular way, and really let the officials, public agencies understand and make policy changes in accordance with this. We may be underestimating the level of planning that we're doing, the amount of capacity that we need over time, but also looking forward, I'm going to be looking into shifts in newer technologies and also just higher levels of automation. Again, this is going to be a long time before we're going to see major changes, especially with connectivity, especially given the political climate. But there's a lot of interesting work to be done, given the fact that we have ACC as the first step, and it's making a fundamental change. And it's not just within civil engineering, it's not just within traffic engineering. This is also an open door for urban planners, especially as to answering questions with how the urban landscape is going to change. Now we know that, okay, some cars are capable of some kind of automation, and it's actually not a negative, and it's not a positive impact, it's actually a negative impact, traffic congestion. How do we plan our cities differently? And many users would, many drivers would not even use this particular automated function, despite the fact that their vehicles have it. So that also opens the doors for behavioral science folks who may have some interest in learning the decision-making process for certain customers or drivers of these vehicles. And also, last but not least, this opens some doors for electrical engineering and computer science, as well as mechanical engineering folks who have a vested interest in designing control systems for automated vehicles. Can this particular algorithm be improved for the automated vehicles, especially with adaptive cruise control, right? So because the fact that there is a delay in response, right? So there is a delay in terms of how vehicles decelerate and accelerate. It has some implications for traffic flow. It has some implications for congestion mitigation. Can we make improvements to the algorithm before we get to connectivity, before we see significant improvements with connectivity? And this can really help us broaden the conversation and make a collective effort when it comes to making our roads more efficient, less congested, and last but not least, environmentally more friendly, because we generate a lot of emissions with urban congestion alone. So want to open to any questions you may have, and hopefully everybody was intrigued by this particular topic that's been floating around in the research community for a while.
Great. Thank you so much, David. And just as a reminder, if you have questions for any one of our two speakers, please write it in the Q&A button in the bottom there. Our first question is for Dr. Besser. If your work led to an application or say federal or support for green space, where as an expenditure of dollars would be the greatest payoff in the inner cities, or where would you expect the biggest payoff of federal appropriations for green space?
Yeah, that's a difficult question, but personally, I would love to bring more green space into cities, and a lot of times that's difficult to do because there's just no space. You know, you have to remove something to then bring in something. You could plant or do pocket parks or things like that, but that makes me think about kind of where I want to go with my future research. So there haven't been many studies on this generally. So we're still trying to understand, how does green space affect brain health? And then we want to know, but how does it affect different populations? So people who are normally socially disadvantaged, you know, lower socioeconomic status, children versus older adults, and people in urban versus suburban environments. So I would really like to aim towards health equity. So that's why I would like to research in the future, kind of how is this affecting people, different kinds of people in different ways, and could we target our interventions at specific people who could have the most benefit, as you say. But I don't think there's strong evidence yet, but hopefully there will be in the future.
Thanks, Lila. Our next question is for David. David, you mentioned that there are potential risks with traffic congestion if you have vehicles on the road that have this ACC. Would that change if every car had the ability to have even the level 1 ACC?
So this is really not a problem not a question about how many people are going to be able to have access to ACC. It's ACC behaves in a way like what I described, despite the fact that it's it's around other vehicles that have ACC. It's not just about being around ACC versus human drivers. It pretty much behaves the same way. It's the inherent nature of response delay that is associated with when it comes to braking, accelerating, that prevents the cars from getting as close together as they safely can, right? Because after you decelerate, they become further apart if the ACC has a couple of seconds or 3 seconds of delay before getting going again. So it's really not about a question of if cars are going to be automated, if more and more cars are going to be automated, what's going to happen? Are we going to see any improvements? It's more about connectivity. How do we leverage 5G technology, and also the institutional barriers related to that? I think there's a lot of work to be done, especially at the policy level, regarding, how do we reconcile the fact that, okay, well, AT&T and Verizon want to make money from you watching YouTube videos on your phone, but at the same time, we have this great concern of using 5G to connect the vehicles together for benefits of reducing congestion, reducing emissions and fuel consumption. So I don't think it's going to be a kind of a free market, private sector type of solution. I think somebody has to step in on the policy side and really deal with this allocation. And this is the difficult part. The technology is here. It's becoming more and more mature, but we're not ready for this bigger shift, right? Are we going to get our Netflix streamed a little bit more slowly because cars are going to connect to each other and they're going to follow each other more closely and not have congestion? So there are conflicting interests. So, and that's going to be, like what I said, a great opportunity for more of a collaborative research, because it involves policy, involves urban planning, involves telecommunications and traffic engineering. Again, overall, we're here to see what's going to happen down the road. Again, nobody has a definite answer, and that's why this field is very interesting.
Great. Thanks, David. Another question for Lilah. With public parks encompassing different acres of space, so you have kind of small parks, large parks, at how many acres do you think a public park starts to benefit the human brain? I noticed you had a little bit of that in your prospective work, but do you have any information on that already?
Yeah, so I think that's, there's always like the rabbit hole that you can go down for research, that there's even more and more you can discover, and there's more complexity the more you look at it. But I will say first that there have been studies that have looked at virtual reality of green spaces, not even amount of acres of green space, and found positive benefit to your attention and your mental fatigue. So that's where most of this work starts from, that green space benefits us in a kind of on our transient state, just how we're doing in a mental state day to day.
You were exposed, let's say you live in the middle of the city, you don't have any green space anywhere close to you. If you had access to virtual reality green space, that would help?
It could help. And even just having a window like I have behind me, and, and that has been shown to be positively affect, better recovery time in hospital patients, just having a window to see green space. So that's kind of where it comes from. But in the studies that have been done so far, looking at parks, how much park space, it seems to be a linear relationship. Like the more park space, the more you have, the better. But you can imagine that, if you don't have community resources, if you're living in a completely rural environment, then you're counteracting the positive benefits of living in an urban area, getting more education, more opportunity, transportation, and those things. So we still need to kind of look at the details of that.
Yeah, great. Another question for David. Our attendee wants to know how you rate Tesla's automated controls.
Well, this is a bit of a little bit of my personal opinion mixed in there as well. The way how Tesla's automated systems are developed is different from a lot of the other traditional manufacturers. The testing is done a lot in the field by actual consumers. So you and I who buy Teslas are sort of beta testers in a way. So a lot of the things that are not fully polished and sorted out are there on the marketplace. And we do see that because they claim that, their ACC system, well, they call it autopilot, is essentially it's ACC that you buy from other manufacturers as well. That can operate on urban streets, that can stop for red lights for you, but also it turns out that they also stop for green lights for you. So there are two different approaches. With the traditional manufacturers, we try to do as much testing behind the scenes as possible and really only roll it out when it's ready. So this is why GM took a really long time to roll out automated lane change, even though Tesla started doing that a few years back. So in a sense that we see evolution of two different approaches. One is let's let the consumer take the risk and see what we get out of it, right? And the other one is let's wait, let's do everything in a controlled environment, and only put it out there when it's ready. So I do like to see a mix of both and not either extreme in the future. That's my personal take on this.
Yeah, very interesting. Okay, the next question is for both of you. Given that, and David, you already mentioned that there's some overlap between both of your projects, right? So the attendee's question here is, how do we as a nation reconcile your two topics? Safe, well-maintained, modern roadways that cost a lot of money, apparently, which I wasn't aware of, and the need to preserve and appreciate and value nature. Are these two disciplines regularly talking with each other and taking the other side into consideration when you're pursuing your research? I don't know which one of you wants to answer that.
Well, I'll go ahead and take a stab at this question. So I think, yeah, there is a lot of reconciliation to be done. Yes, we've been talking a lot about, engineers collaborating with planners. I think there's been quite a bit of a history for that. But here is the disruptor in the mix, right? We have, well, transportation really isn't much about tech companies until recently. So we have a disruptor, such as Uber, and I think we can get past that right now. They're becoming a little bit more familiar, but now the biggest disruptor is the auto manufacturers. Because cars are not driven by humans anymore, at least down the road, that's the trend we're seeing. They are actually taking control, and essentially manufacturers are designing algorithms that are affecting how congested highways are going to be down the road. And they are not consulting with us, the engineers who manage the infrastructure, and also planners. So in a way that I would expect some kind of collaboration, some kind of conversation, also with the manufacturers, that could play a significant role. So their objective right now is to minimize the fuel consumption of that one particular vehicle, because as a customer, as a client, that's what you care about. But because of their algorithm, because of that, as you saw in the video, the delayed response leaving an intersection, everybody else in the back has to decelerate. Now, sure, you may slowly accelerate out of that intersection. You may save your own fuel, but what's going to happen is that it's going to cost a lot more fuel for the other folks right behind. And as an aggregate, collectively, macroscopically, we're looking at worse fuel consumption and more greenhouse gas. So I think it's good to have the tech companies, and especially the vehicle manufacturers, who are going to be bringing these disruptive technologies, quote unquote disruptive technologies, into the mix. I would like to have them on board with this conversation about how do we mitigate congestion and how do we plan our cities. And also, maybe this is a big phrase to say, but be regulated, right? So I think some kind of management is going to be have to be done at that level. Right now, we just don't understand what the implications are, and that's why my research would like to alarm people about the implications and really bring this important question and concern that that manufacturers is playing a serious role that could affect our way of life. And it's to a level that we've never seen before.
Great. Lilah, do you have anything to add to what David was saying?
I'll just quickly, I could go off onto semi-tangent, but related to his work, if you think about automated vehicles, I mean, my first thought is if we reduce traffic, then we will get away from this automatically widening roads and widening roads and widening roads, and that affects our green spaces and the areas, nature and preservation of it. So it's possible that those could be intertwined in that way, that, you know, our land could be preserved if we can reduce traffic flows that then normally cause people to just continually widen roads. But also just, you know, urban planning tends to think about things comprehensively. There's a lot to consider, including park spaces, waterfronts, transportation, drivers, but also pedestrians, bicyclists, all these things. So I think it's a tough job to kind of coordinate that, but normally it's, you know, taken in consideration. And there are projects that do something like that, normally not focused on cars so much, but how do we get people out of cars? So like the Atlanta Beltline focuses on converting old railroad systems to light rail, and then also increasing park space in the Atlanta area. So that's, you know, projects like that kind of do both.
All right, we're almost out of time. Let me ask one last question, and I know we have a couple of more. I may send those to you individually, and you can answer those. So the last one is for David. As improvements are made, would you expect autonomous vehicles to react timely and appropriately to road hazards in the future, like a tire blows out or debris falls out of a truck on I-95 or something like that?
Certainly with the field testing I've been doing, to a large extent, yes. And you know, it's not always perfect. So this is why I kind of stress not just you know, not just at the level of reducing traffic congestion, but also, yeah, also important point can be made for safety, right? We need connectivity to be able to you know, go beyond just the sensors themselves that are going to detect immediate areas and respond accordingly. Sure, they have some capabilities of doing that, but what I realized is that during field testing, again, I did not put my students at significant risk, but some nuances we kind of found is were that you know, if you see the objects in a different angle, it could behave quite a bit differently. So I think what we can what lesson we can take is that without connectivity, we really can't check all the boxes, and that's when things become I wouldn't say more perfect, but more revolutionary. That's hopefully we'll see that at least maybe within the next 2 decades or so.
Great, thanks. I'm having one more question after all, because I find it very interesting. So Lilah, this one is for you. I think that's a really good question. What role does air quality play along with green space, and how do you control for that in your study? For instance, if a park could be located close to a polluting plant or industry, it may impact health, perhaps not cognitive function, but other indicators of health.
And sorry, I'm having a coughing fit. Bad time. No air pollution in here, but yeah, so air pollution is of interest to study in my research. I actually think green spaces may buffer against air pollution, and there have been some studies evidencing that. So of course, if you have a bigger green space area, then you're buffering against traffic related air pollution, but could be other buffering against other kinds of pollution. But also it may be kind of a sink for kind of gathering up some of the pollution in the air. So that people posit that it's a positive benefit. If you have a lot of green space, then probably reduced air pollution exposure. The caveat is that with more trees, you have more allergens. So people that are sensitive populations, you know, it could be a trade-off for those people, because if they have some kind of asthma, then they're still exacerbated in those areas. So it's still being looked at in the field of green space and cognition, but yeah.
Great. Thank you. So with that, we're actually at the end of our time here. So thank you very much, Lilah and David. That was very interesting. Thanks everybody for attending. Have a great rest of your day.